Welcome to the deep dive. Today, we're tackling something that, well, it sounds like a contradiction, doesn't it? Aviation decarbonization.
Right.
Yeah,
You hear constantly about more flights, more demand, rising emissions globally.
exactly. But here's the twist. The industry has actually been getting cleaner steadily since the 1970s, so our mission today is to unpack that.
Yeah, how do they manage that? We'll look at the planes, the fuel, even how they're flown.
Okay, let's dig in. To really get this, we have to start with the machines themselves, the aircraft and engines. I mean, the changes are dramatic.
Oh, absolutely.
How did jet engines get so much, well, thriftier with fuel?
It's a huge technological leap.
Mhm.
So back in the 70s, you had engines like the Pratt & Whitney JT9D. Their bypass ratios, maybe 3.1, perhaps 5.1.
And bypass ratio, just quickly.
Right, think of it like this.
Well,
Older jets, they mostly shot hot gas straight out the back. Very powerful, but not super efficient.
okay.
Modern engines, though, like the Genie 9X or the Rolls-Royce Trent XWB, we're talking bypass ratios over 10.1.
10 to 1.
Yeah. They act more like massive ducted fans. Most of the air goes around the engine core, not through it.
I see. Pushing more air, just
Yeah.
differently.
Exactly. And that massive bypass, that alone gives you a 15, maybe 20% gain in fuel efficiency per engine.
Wow. Just from that design change.
It was fundamental. It's part of what made really long flights affordable for more people. Even as planes got bigger and carried more passengers.
So more flying, but each flight was getting cleaner per person. That's clever engineering. And it wasn't just the engines, was it? The actual body of the plane.
No, you're right. Materials were absolutely crucial. We moved from, well, mostly heavy metals
Right.
to these incredibly light, strong composite materials. Think carbon fiber reinforced polymers.
Like on the Dreamliner, the 787.
Perfect example. The Boeing 787 is about 50% composite by weight. That makes a massive difference.
Lighter plane, less fuel needed to move it.
Yeah.
Simple physics, I guess.
Basically, yes. And you combine these engine and material improvements.
Yeah.
Between 1960 and 1980 alone, fuel efficiency shot up something like 55 to 67%.
That's incredible. 67%.
And it continues. Modern planes like the 787-9, the Airbus A350-900, they're just incredibly efficient machines compared to their predecessors.
Okay, so we have these much better machines, but they still need fuel. How did that side of the equation change? Did the fuel get cleaner too?
It did, yeah. Back in the 70s, Jet A1 fuel was, well, pretty basic kerosene. It had impurities like sulfur.
Which isn't great for emissions.
Not at all. But modern Jet A1, it goes through advanced refining processes like hydrotreating, hydrocracking. They essentially scrub the fuel clean.
So fewer pollutants straight out of the refinery.
Precisely. It burns cleaner, more efficiently, and actually cleaning up the conventional jet fuel was really important groundwork
How so?
because it paved the way for sustainable aviation fuels, SFs.
Ah, SFs. That's the big buzzword now, isn't it? How do they fit into this historical picture?
They're potentially transformative. The key thing is SFs are often blended with that modern, clean Jet A1.
So you can use existing planes, existing airport infrastructure.
Exactly, which is vital for getting them adopted widely.
Hmm.
And the best part, SAFs made from things like used cooking oil or agricultural waste or biomass.
Yeah.
They can cut life cycle CO2 emissions by up to 80% compared to the old fossil fuels.
80% reduction, potentially. That's huge.
It is. So you see this evolution, cleaner, conventional fuel, making it possible to then blend in these even lower carbon alternatives.
Okay, so hardware fuel. But there's more, right? You mentioned smarter operations. That sounds like the human element, maybe data.
Absolutely. It's about how airlines and pilots actually fly the planes. Subtle changes, but they add up significantly across thousands of flights.
Give us an example. How do you fly smarter?
Or take flight planning. It used to be more about fixed airways, right?
Yeah.
Stick to the path.
Okay.
No, pilots use dynamic tools. Flight Pulse is one example. They get real-time weather, real-time traffic data.
So they can adjust on the fly.
Exactly. Pick the most fuel-efficient altitude, find the best route around bad weather or congestion. Avoids unnecessary flying, saves fuel.
Makes sense. More flexible, more responsive. What about on the ground? Any savings there?
Oh, definitely. Think about taxiing after landing. More airlines use radii-reduced engine taxi-in,
Meaning?
shutting down one or more engines once you're off the runway.
Yeah.
Why burn fuel with all engines if you don't need them just to get to the gate,
Right. Seems obvious when you say it.
doesn't it? And minimizing APU, use that little engine in the tail by plugging into ground power at the gate. Also, strategic fuel management.
How has that changed?
It used to be common practice to carry quite a bit of extra fuel, just in case. Conservative planning.
Better safe than sorry.
Sure, but extra fuel means extra weight, which means burning more fuel to carry it.
Vicious cycle.
Kinda. So now it's much more data-driven. Sophisticated analysis helps calculate exactly how much fuel is needed, plus necessary reserves, but minimizing that unnecessary extra weight.
So it's these cumulative gains, smarter routes, smarter taxiing, smarter fueling, flight after flight.
That's the idea. Leveraging data, refining procedures, small changes, big impact overall.
It really is incredible when you piece it all together. The engineering, the chemistry, the operational smarts, all working since the 70s to decarbonize flying, even as it grew.
Yeah.
We set out to unpack this contradiction, and I think we have. These innovations are clearly how it happened. So where does this leave us looking forward?
Well, look, the progress is undeniable, but challenges definitely remain. SAF production is still way too limited, for one.
Right, scaling that up is key.
Absolutely. And we still need those bigger breakthroughs.
Yeah.
Things like hydrogen power, maybe electric propulsion for shorter flights. They're still further out for mainstream long haul.
So an important question hangs in the air, maybe.
I think so. How much more can we squeeze out of these current technologies, the incremental improvements in engines, airframes, fuels, operations, before we really need those entirely new propulsion systems to take over?
That's the big question.
No. But the takeaway for today, I think, is that even though total aviation emissions might still rise because more people are flying, the emissions per passenger have plummeted.
So that lower carbon future for flight, it's not just aspirational talk.
No, I'd say it's already unfolding. We're living through a massive, decades-long efficiency improvement. The journey's far from over, but it's well underway.